Have started. Thank you for your patience, everybody, while we get up and running here with today's webinar. My name is Patrick Madden. I am the current president of the New England chapter of the American Association of Public Opinion Research. And again, want to welcome to our fall webinar for today. The topic we'll talk about is practical applications of AI in research. And we do have four great panelists today that really will share more about the ways that they're using it in their work for more practical applications. And this webinar is really inspired by a lot of what we saw at the 2025 NEAAPOR conference. I think they're at that conference in St. Louis. There's really a lot of great presentations on AI. And we saw this really as an opportunity to kind of continue to share the work that is being done in this space, as well as to keep the conversation going. So again, we will have a section at the end of our set of presentations today to have a Q&A for any questions out there. And again, we just want to thank you all for joining us today. And again, be on the lookout after this webinar for our spring webinar coming up in 2026. Again, thank you for joining us. And with that, I'm going to hand it off to my fellow council member, Travis. So Travis, take it away.
Awesome. Well, thanks, Patrick. Hi, everyone. I'm Travis. I'm the program chair at New England NEAAPOR. And so thanks for joining today's session about AI for research, especially with a strong focus on survey research. And I'm very excited to be joined by an exceptional panel of experts and to talk about topics from cognitive interviewing to data cleaning all the way to data analysis and survey open-end coding. So we have four panelists, and so first we have Hanyu Sun, who is the Associate Vice President of Statistics and Data Science at Westat. And then we have Tom Tuccio, who is the Product Manager for Quality Score at Dynata. And then we have Jacob Nelson, who is the Senior Data Scientist at the Harris Poll. And finally, we have Sarah Kahl, who is the Account Manager at Ipsos. And for today's session, each panelist will first start with a very short 7 to 8 minute presentation on the topic. And then after the presentations, we will have about 20 minutes for the Q&A session. So with that, I think we can just get started. So first, I would like to welcome Hanyu Sun to present her topic. Hanyu. Yeah, I think you're probably on mute.
Sorry, I was trying to find the unmute button for myself. So let me share my desktop very quickly. Okay, great. I think that works. Thank you, Travis. So today I'm going to present a proof of concept study that examines the use of large language models for analyzing cognitive interview transcript. So first, I'd like to acknowledge the contribution of my co-author, Alexis Kokoska, on this study. And this proof of concept was conducted in February 2025 and was first presented in NEAAPOR, the annual conference 2025. So cognitive interviewing is a quantitative technique that is widely used to test and develop survey questions. So it focuses on the cognitive process that respondents use to answer questions. Think aloud and the verbal probing are two commonly used techniques in cognitive interviewing. So for think aloud, respondents were specifically instructed to verbally describe their thinking process used in arriving at the answer to the question. While for verbal probing, the interviewer asked specific information relevant to the question or the answer the respondent provided. So the goal of using these techniques is to gain insights into the respondent's understanding of the survey question as intended by the researchers. So this also makes the conversation between the interviewer and the respondent in cognitive interviewing differ from everyday conversation between two speakers. So recently, as we know, there has been increasing interest in the use of large language models in survey research. So the open question is whether and how to use large language models to improve the efficiency and effectiveness of cognitive interviewing. So this flowchart represents the general process of conducting a round of cognitive testing for questionnaire development. So as shown in the flowchart, A 1 hour interview may require 2 or more hours for an interviewer to write up the notes. And then the researchers will need to review all the notes across interviews to report findings at the question level to inform any wording changes. So one way to improve the efficiency and effectiveness is to have human interviewers focus on conducting the interviews while utilizing large language models to code and summarize the interviews. So subsequently, human coders can perform quality control on the model output. So a baseline, it's just some very basic background information. So baseline large language model is a machine learning model that has already been trained on a large data set for a general task, such as language understanding or speech processing. And fine-tuning is a form of transfer learning. So fine-tuning a model involves starting with a base model and making targeted adjustment to its top layers parameters to adapt it to a specific task. So fine-tuning is beneficial because it saves time and resources. It helps the model learn patterns relevant to a specific task, and it can adapt with far less data than pre-training since the model already knows general language patterns. So in this presentation, we address 3 research questions regarding the use of large language model to analyze cognitive interviewing transcript. So first, we'd like to see whether a fine-tuned model produced coding results of higher agreement to the human coded benchmarks compared to the base model. And next, whether the coding results from a slightly larger fine-tuned model outperform those of smaller fine-tuned model based on comparison to the human coded results. And finally, to what extent the coding results from 2 rounds of the same fine-tuned model align with each other. So it's more about reliability. So as we know, fine-tuning requires the use of smaller label dataset of a specific task. So for this POC, 2 coders coded like 18 cognitive interviewing transcripts from the American National Election Study 2006 pilot study. So the transcripts are publicly accessible on the study's website. Coders coded each question answer sequence of an interview to assess respondent behaviors at the full response stage. So include comprehension, retrieval, judgment, and responses. And the decoder double coded a random 5% of the question answer sequences, and the Cohen's kappa was 0.72, which is considered like substantial agreement from a behavior coding perspective. So we fine-tuned like 2 models, Meta's Llama 3.23b instruct and the 1b instruct. Both are lightweight text-only models that can run on modest hardware. We fine-tuned both models using PIFT with LoRa or low-rank adaptation. And we use Unfloth to optimize memory use and improve speed for fine-tuning. So we provided some information about the training setup as well as the hyperparameters for the inference. Okay. So to answer the research question on coding, we fine-tuned the 2 models using a total of 621 label question answer sequences from like 15 interviews. We then applied the fine-tuned model to predict response behaviors for the remaining 103 question answer sequences from like 3 interviews. These 3 interviews were randomly selected from the 18 label coded interviews. The prompt we use is displayed on slide. So we asked the model to analyze the provided conversation between interviewer and respondent for kind of testing survey questions to provide some context about task. And then we asked the model to specifically identify issues associated with the 4 stages of response. And finally, we asked the model to like quote respondent speech to support each identification of an issue and provide a very brief explanation. So results. So first, to provide some context, let's go over one example of coding results by a human, fine-tuned model, and the base model. So let's start with the first column, the transcript. So in the transcript, as you can see, the interviewer asked the question, in group of peoples, I'm rarely the center of attention. So this is an item from a scale asking respondents whether the statement is true or false as applied to them. The respondent said the statement is true. Then the interviewer followed up with a verbal probing asking the respondent to describe their thinking process. So the respondent then provided information on how they arrived at the answer to the question as shown in the transcript, marked in red. There were many failures like ums and ahs in the respondent's speech, as well as restarts like I don't try to get so speech like this is very common in cognitive testing because respondents not very familiar or used to deliberately describing their thinking process as compared to everyday conversation. So the fine-tune model, that's the third column. So the fine-tune model produced the coding results the same as human coding. There were no issues with comprehension, retrieval, judgment, or responses on that specific conversation. However, if you're looking at the last column from the base model produced a very high rate of false negatives. So basically said there were issues with the respondent speech on every stage of the response. So as a reminder, for research question 1, we're trying to answer the question whether a fine-tuned model produced coding results of higher agreement to the human coding benchmark as compared to a base model. The answer is yes. So fine-tuned model outperforms the base model. So we compare to just first research question, we compare the fine-tuned and the base model, like 3B, the 3.23 billion instruct model, on the full survey response stage. So we'll start with comprehension. So for comprehension compared to the fine-tuned model, the base model resulted in substantial lower prediction performance with much higher false negative and false positive rates. So the fine-tuned model demonstrated acceptable level of performance given the complexity of the coding task. So next we look at retrieval and judgment. So the test data set, the 15 interviews we coded, includes a few incidences of retrieval and judgment issues. Since most of the ANES questions are attitudinal questions, don't have that many factual questions. So due to the highly imbalanced distribution, we focus our evaluation on the confusion matrix. So regarding retrieval, out of the 103 test question answer sequences, the base model produced 92 false negatives, while the fine-tuned model produced 0 false negatives. So both models produced about 2 false positives. And regarding judgment, very similarly, out of the test question answer sequences, the base model produced 98 false negatives, while the fine-tuned model produced 0 false negatives. So both models produced about 0 false negatives. And finally, the response stage. So for response, out of the 103 test question answer sequences, the base model produced like 91 false negatives, while the fine-tuned model produced only 2 false negatives. Both models produced about 5 positives. The base model produced 5 false positives, while the fine-tuned model produced about 7 false positives. So as I said earlier on, the training data set is highly imbalanced. The fine-tuned model is conservative. While it correctly identified over 90% of the true negatives, it missed about 50% of the true positives. However, it still outperforms the base model in terms of response. So research question 2, that's where we examine whether the coding results from slightly larger fine-tuned model outperformance of those of smaller model based on comparison to human coding benchmark. The answer is yes. The fine-tuned larger model outperforms smaller model. So given the time, I'll just go through the table very quickly. As you can see, on all the stages, very similarly to what we saw early on, the slightly larger model had a better performance as compared to the fine-tuned smaller model in terms of the 4 stages. And finally, we want to know to what extent the coding results from 2 rounds of the same fine-tuned model align with each other. The answer is they have a very high agreement rate. So we use the fine-tuned 3.23b instruct to produce predictions for the same 3 interviews twice to mimic like 2 coding instances. And that's where we say a agreement rate of 96.1%. So conclusion, in this proof of concept study, we fine-tuned large models using a few hundreds of labeled question answer sequences. We found that fine-tuned model produce coding results of higher agreement to the human coding benchmark compared to the base model. We also found that fine-tuned results from a slightly larger model outperform those from a smaller model. And in addition, the same fine-tuned model was used to produce coding results for the same data set twice, producing high agreement between rounds. And for next step, this POC shows some promising results. So for the next step, we will consider about increasing data set size to improve generalization and validate on cognitive interviews from various different projects. We can fine-tune a larger model for each of the response stage with larger training data set, or we can also consider about multi-stage fine-tuning approach for sequential tasks like coding at first and then summarization. So in addition, we will develop a scalable product that can be applied across projects utilizing cognitive interviewing for questionnaire development. So for example, integrating speech-to-text and fine-tune modeling as one step. That's it. Thank you.
Well, awesome. Thanks, Hanyu. So next we have Tom to talk about data cleaning and fraud detection. Tom?
Thank you very much. Can you see my slide?
Yes.
Excellent. All right, well, thank you guys very much for having me today. The challenge that was put to me ahead of this was to think about where we as a company have been able to find and leverage AI and bring it into our workflows to try and optimize some of the actual processes, some of the tasks that are being done by our teams. And at Dynata, we use AI in a lot of different places, but the one I'm going to talk about today is specifically our quality score tool, which we use for data cleaning. So my goal today is to talk a bit about how our team found success in leveraging an AI-driven solution in our data cleaning workflow and what the results were. And we will talk about some special considerations, things to watch out for as you look to integrate AI into your surveys. But first, stop me if any of these comments resonate with you. You may have heard some of these recently. In fact, you may have heard some of these when you were catching up from your weekend this morning. We are in an evolving technological world, and our clients and other stakeholders are really feeling it. With so many new technologies on the market, so many concerns about security and fraud online, clients are concerned about how much time and effort they're investing in keeping their data clean. And additionally, they're worried that they need to make sure fieldwork stays on schedule, and they're trying to create scalable and repeatable processes. And oftentimes the feedback I hear is, hey, we're spending as much time fighting fires, or at least trying to prevent fires, as we are actually generating insights and adding value to our research. That's not what we're here to do. We're here to add those insights and value. And this is where AI can really be helpful. When used correctly, AI has massive potential benefits. It can make your teams more efficient and better able to focus on high value work instead of repetitive and mundane tasks. It can bring consistency to your teams by giving everyone the same starting points and foundations in their work. It can improve the trust you have with your stakeholders, as AI can help you with your findings and to deliver insights that were never available before. It could also demonstrate your desire to change with the times to the market. And finally, it can open up future pathways. What you discover quickly when you begin successfully leveraging AI in one part of your business is how many other areas of your work could also benefit from this kind of a technology. In Dynata's case, we had a problem. It was 2020, 2021, and we found ourselves spending way too much time cleaning data. We had a massive volume of data. We had 20 million respondents annually and growing that needed to be cleaned by our teams. And this was causing big delays in field work, mainly driven by the need to stop, do these data checks, perform manual cleans, and then go try and reconcile multiple systems so that our quotas were always up to date. We also knew that there were new fraud techniques entering into our surveys, techniques that avoided historic programmatic checks and that were really difficult to catch by humans. And because our process was so manual, it also wasn't very scalable, meaning that great ideas and learnings from one team were slow to be adopted by other teams globally. We knew we needed a solution that was easily adaptable and could integrate seamlessly. It needed to be transparent enough to be trusted by our staff, and most importantly, it needed to save time. So enter quality score. So what is quality score? Well, briefly, quality score is Dynata's AI-driven machine learning model, which is used to evaluate a respondents in survey behavior. It analyzes over 175 metrics in real time and compares respondents to others within the same survey, which means that it's adaptive and intelligent. It not only scores respondents, telling us if they're worth keeping or not, but it provides supporting data, which can help explain its decisions and instill confidence that the right call is being made. And it can automatically flag respondents for removal and replace them in real time, meaning that your quotas are always accurate and aligned, and your fieldwork is better able to stay on schedule. So in short, it's using AI to replace inconsistent and time-consuming manual validations with an efficient and scientific process. But stepping back for a minute, there are challenges when you try to introduce AI into your business, and there are a couple of concerns you will face, and we certainly learned these with quality score. These types of challenges may vary or present themselves differently in your unique circumstances, but there are three categories I want to address today. The first is that AI is a black box and it's really hard to explain. And this is the most common one. And the workaround here is to make sure that your AI solution is built on real user stories and designed to actually solve user problems. Also, make sure your key stakeholders are involved and invested in the design of your solution, and make sure that your AI can show its work. Make sure there are realistic expectations and outcomes as well, because AI is not perfect. So you need to be careful not to overpromise and underdeliver. Next is people may not trust how your AI was created or what your models are trained on. And this is very valid, because if your model is trained on garbage in, you should expect garbage out. To solve for this, make sure you're careful with what data you're selecting and training your models on, and encourage feedback from all your users. Promote full transparency and spend the time to develop an accurate way to capture successes and failures. Those are both going to be useful to you in future iterations. Finally, be aware that introducing AI's automation can actually be really disruptive to existing processes, especially those that are trusted for their long-standing use in their history. And to this, I say, start small and scale big. Find ideal places to test your AI and carefully monitor its success and document user input. Communication is key. So if you want to scale large before you start small, you need to expect big consequences. So what happened in our case study? Well, because we were proactive in facing those challenges, we actually had great success. We reduced the time project managers spent cleaning their data by as much as 85%, which let them really focus on truly understanding and adding value to their client studies. We also made our field schedules a lot more reliable and predictable, and we were able to create a strong data cleaning foundation that scaled globally. Once teams had these starting foundations and quality score, they could even then go and fine tune and customize as needed to their unique clients. So we weren't removing all those historical backgrounds. We were just getting everyone from the same starting blocks. We were able to develop learnings and insights on fraud prevention that were never possible before, and we brought this higher level of quality to our clients. And finally, we were just able to reinforce our position in the marketplace as a company who's committed to adopting new technologies and changing with the times. We weren't hiding from fraud, we were tackling it head on. And we showed we were ready to future-proof our research with and for our clients. So in conclusion, I want to leave you with a few final thoughts. AI can amplify your teams and act as a force multiplier when it's deployed correctly. It can let your team spend more time doing meaningful work while it takes on the repetitive tasks. You must be careful, though, to consider your stakeholders' trust, which means being ready to show your work. So in our case, we did this by providing catered supporting data that spoke to the actual needs identified through our user stories. But consider what data your teams will want to see before they trust any AI automation. Because if you fail to break open the black box, you should expect slow adoption. Make sure you start small and then scale what works. Don't make the mistake of diving into a new technology or process before you test it in a controlled way. For example, we started with select teams on select types of work before we scaled quality score globally. And this gave us a chance to gather really important user input that we needed to make our solution useful to the masses and to create next steps that would drive further innovation. And finally, don't think about adopting AI in your work as just a technical upgrade. You need to think about it as a cultural shift and as a commitment to the future, as a way of empowering your teams to do their best work and to find and deliver the highest value possible to your clients. And that's it for me. Thank you so much.
Awesome. Well, thanks, Tom. So next we have Jacob to talk about using AI for data analysis.
Okay,
Jacob.
great. Can you hear me okay, Travis?
Yes, perfect.
Awesome. I'm going to share my screen, which I believe should be working now. Okay, can you see the screen, Travis?
It's loading. Yep, I can see your screen now.
Excellent. Okay, so hello everyone. My name is Jake Nelson. As Travis mentioned, I'm a data scientist and researcher at the Harris Poll. I'm thrilled to be speaking to you today. So the motivation for this talk is that, as survey researchers and market researchers, et cetera, we're seeing AI dominate the headlines, and there's a lot of pressure to use AI. And they often come with, tall tales of big dramatic breakthroughs and ambitious projects. And but what I want to talk about is that most of us just want practical everyday improvements to our workflows that actually get our work done. And so that's what I want to talk about today, is that is kind of that we don't need to go for the moon. We can do small AI wins today, and specifically in data analysis. And so we're going to focus on the realistic and achievable ways that we can do that. So let's dive in. So who am I talking to in this talk? So those would be the data analysts feeling kind of the AI pressure, the pressure to use AI but are unsure where to start, and any researchers who have repetitive tasks in data analysis. And so while everyone's talking about, as a goal for us, everyone's talking about using and building big rocket ships, sort of as the metaphor, right? And big AI workflows or products that do a lot of things and promise a lot of amazing results. But really what most of us need is a reliable bicycle first, or in other words, just a small product that does one thing really well. And so that's what I would like to do, is to kind of take away the intimidation factor and have us start small. So today I'll be talking about agentic AI, and that is and the difference between the two, between traditional AI and agentic AI, is that traditional AI will answer your question, and agentic AI can actually do tasks for you. It's kind of like a tireless intern that can access all of the tools that you have on your computer, access the data that you have on your computer, and knows about your workflows and knows what the standard operating procedures are. And why this matters is that we can start to, most of us do kind of the same tasks every day, and AI can take those things off of your plate. And it removes a lot of cognitive burdens for the researcher, because not only can we automate tasks, but we can automate the decision making for those tasks. We can know, we can have the AI decide when to use a tool and when it is appropriate to run a specific task. So as a real example, we could prompt the AI to say, create multiple crosstabs with age as columns and variables associated with political and social identity. Assuming that my data has those variables, it would be able to first access my data, and then understand where the variables are that it needs to pull, and then run a crosstab or a set of crosstabs with those variables and show you the results. So when you are running your first AI assistant task, just identify a small thing that you can delegate to it. And so in my working example that I mentioned, we're going to do a simple task. Make cross tables for any two variables in a specific data set. And so this would be an AI agent that can do only 4 things. Right? It can read my data file. It knows about the variable names and what they measure. It can create crosstabs on command or on prompt, and then it can format the results for you, so that you can see the crosstabs for yourself that it runs. So you don't need very much to get this done. All you need is an OpenAI account with an API key, or it can be another service account like Anthropic or Gemini. You need just some basic programming knowledge. I'm using R. You don't need very much programming experience. A basic R knowledge would be sufficient. For instance, if you can run a crosstab in R, you can do this. It takes maybe 30 minutes of setup time if you know what you're doing. And in R, there's a tidyverse package called the Elmer package, which is newer in the last year, that works really well for accessing AI services like OpenAI. For this example that I'm taking us through, all I did was write 3 functions and gave the AI agent access to those functions. So there's one function that's going to read my SPSS file, my data file, a function that does goes through that data file and accesses all of the data names and labels and value labels, and a function that just runs the crosstabs. And so, and to set that up, you would just run, you would set up a chat object in R like this, and register tools to it. So you would register a tool like my read my SPSS function. You could just register a tool with the tool function and just tell it what to do and how to use it. Then once that's done, that's all you need to do to start using the agent. There are 4 ways that you can engage with it. You can run it in R with like a $chat function. You can interact with it live in the R console or in the browser, or you can integrate it within a Shiny app. So for example, I pulled this ahead of time just in case it didn't load, because my computer has been a bit slow today. But in my example, all I did was say, show me a crosstab of age by who they voted for in the last election. And the OpenAI agent came up with, started going through the tasks that it needed to do, identified the variables that it needed to run it by, and then generated for me a crosstab of that came from my data that was run on my computer, and I can go back into the logs and see exactly what functions were run to generate these results. And it shows me a crosstab of age by presidential vote choice, as well as statistical significance tests that happen in the second rows of each major row here. And it also gives me a little synopsis about, like, okay, well, what are the key findings here? So the point being is that, like, we don't need to go for the moon in a complicated AI product. You can start embarrassingly small like this. Your first AI task or AI agent should be doing something that you do weekly or often and takes 10 or more minutes of manual work, and has clear inputs and outputs. So some examples could include data labeling, some crosstabs, analysis, basic analysis that you do, maybe file organization that needs to be done, etc. And then once you do something simple, you can push further. You can develop like a stronger repertoire of many tools. So you could equip it with many data wrangling tools like filtering or stacking or imputing. You could have it analyze data with regressions, correlations, or other more complex models that you have for your organization. You can do data visualization. You can export data. You can build reports. You can mess around with the prompt engineering. You can fine tune your models. You can do nested agents, and you can deploy agents on MLOps platforms for agentic AI at scale. So I would recommend, if you want to get started, looking at the Elmer package. It has a lot of useful and accessible articles that will take you through how to use this and deploy it on your end. Thank you so much. Let me know if you have any questions. Please feel free to reach out to me.
Great. Thanks, Jacob. So next we have Sarah to talk about using AI for coding open ends. Sarah?
Hi, everyone. Please let me know when you can see my screen. I think we should be good to go. But today we'll be talking about coding of open ends. There's specifically one example that we ran just a couple of years ago, actually around this time in November, about veterans. And so with that, let's get right to it. Let's see. There we go. Okay, so as I mentioned, we ran a Veterans Day survey with our nationally representative panel, knowledge panel that Ipsos owns. And we included specifically several open-ended questions. So we had one that was shorter and one that was a little bit longer, where respondents could write up to a paragraph or so. We initially used just human coders, if you will, so my teammates, and we wanted to see how AI would do in coding these same open ends. Earlier in the year, we launched what we call Tactic, which is a GPT-4 powered coding tool that Ipsos owns, to see how they would code the open ends and to ultimately see what the differences were between the humans and utilizing AI here. So specifically with these two open-ended questions, we had, what are the top 3 words when you think of veterans or Veterans Day? And then it was a very short text entry. And then the second question was, what does Veterans Day mean to you? So here we could see how AI and humans would code just one-word answers versus how we would code a longer answer, so sentences, paragraphs, etc. Okay. So a little bit more about tactic before we get into the real meat and potatoes of the analysis here. There are multiple uses that tactic has as a tool. We, for today, will focus more on the text coding and the sentiment analysis, as we wanted to see where would we group certain responses. But there are other ways that we can use tactic, which is great. And we are still developing this tool even today. And then something else about tactic that is going to be important for our analysis is the coding frame. So you can upload a custom code frame where, the principal investigator or whoever can upload, okay, please code into these X, Y, and Z categories. We can also have tactic, the AI tool, come up with the codes themselves, which is fascinating. So if we feed, hey, here are all of the verbatims or here are all the open ends, it can take that and then create its own coding frame. So we wanted to test this as well. And we'll get into that during the analysis. So for our coding approach, we had 2 human coders, and we also processed the responses for the open ends twice through tactic, which you'll see as tactic 1 and tactic 2 in the analysis. And so this gave us 2 different human, codings, if you will, and then 2 AI runs as well, just so we could have more data to work with. And then to enable all of the direct comparisons, we applied the same code frame for each. So for the analysis, there was a frequency tables that were created to compare top codes, so the ones that were used most frequently by all 4 different coders. And similar to Hanyu, to your presentation, we also utilized a kappa statistic as well to measure for inter-rater reliability. So how much in agreement are human to human to AI, and AI to AI? Are we putting things in the same codes as AI, and are even our 2 humans, how closely are they coding things the same? And then how closely are AI coding things the same as well? So just to give you a visual representation, these are some of the words that were given for that first question of what are the first 3 words that come to mind when you think about veterans. So you can see service, brave, honor, sacrifice. These were really the words that came up. And for the coding frame, this coding frame was done by our team, by the principal investigator, so not by AI. So when we ran this question through tactic, and I think we did it 3 separate times for the 3 different words, we were always feeding this specific coding frame that you can see up on the screen. There's a total of 18 codes with an other. And then if we look at the actual agreeability, we saw that human coders demonstrated very, very high agreeability. They were more likely than not putting things into the same group as each other. So I did want to point out here, as you can see on the right, that there was a little bit of human error. Someone coded something as 19, and if you remember, there were only 18 codes in the other. So it's just something to note that AI wouldn't necessarily make the same mistake, right? So this is something that is pure human error. We wouldn't really see that with AI. So similarly, when we look at the agreeability between AI and AI, we see that the kappa statistic is also quite high, and they are more often than not agreeing with each other, which isn't entirely surprising. So when we look at the human to AI agreement, this is where it is a little bit less strong, as you can see. So there are obviously a couple of groups that are driving the statistic down. You can see it with heroism, hardship, and we'll get into where they are disagreeing a bit. So it's not not as strong as the other two groups, but still strong for these one-word answers. So where was this disagreement? Well, first, sorry, let's see where, there we go. So if we look at how frequently things were being coded, so number of cases here, and here's where the code ranking was, we saw similar code distributions. We actually hypothesized that humans would use similar codes more frequently because it's whatever comes to top of mind. But however, we didn't actually see that. We saw that they really used the whole variety of codes similar as AI did. So this is percentage of cases coded based on most popular to least popular. And here we can see across the diagonal on this chart here where the humans and AI were agreeing. So you can see that there is a couple of where they really just did not agree. If we see this 21% here, that's for selflessness. So this 21 is a really, really low agreement. But we can see for a lot of what humans coded for selflessness, Tactic coded it more with heroism. They used a different code here compared to the humans. So there was a little bit more variability with Tactic, but it really had to do with the coding words themselves. And I can show you that on the next slide. I'm going to skip over this one for now, just for sake of time, and just go into this one where it's a little more clear. So for example, where Tactic really had that differentiation between humans was with codes like hardship. So when people wrote in words like hard worker, hardworking, etc., Tactic saw that word hard and put it into the hardship category rather than a more relevant category for these words. So something as nuanced as this will throw off your data and your analysis when utilizing AI in compared to what humans would do. As a human, our human coders would see hard worker and certainly not put that into the hardship category, right? So this is definitely something to note when moving forward, utilizing AI with coding of open ends. And really quick, I know that I'm running out of time, but for our second question, this is kind of, again, that visual representation of what came up for what does Veterans Day mean to you? And for this one, we had Tactic come up with the coding frame. So it wasn't from the humans. We ran it through that first run with Tactic and we said, hey, please provide a coding frame. They gave us 34 categories. And as you can see on this next slide, there are a lot of redundancies. So that first run with Tactic came up with a lot of things like Veterans Day disregard, Veterans Day indifference, very, very similar, right? So we did note that there were a lot of these, but for the sake of the project, we kept all of these because we wanted to see what would happen again when Tactic ran through it a second time. So this is the coding frame, and this could be due to longer responses and also the coding frame at hand. There was a lower agreeability across the board. Humans to humans still had the highest, and then AI to AI had the second highest, but there was less agreeability across the board, especially when it came to the human AI pairings. And you can see that in the sheer amount of codes. So Tactic 1 really did use all of the codes that it came up with, but there was a less frequency on Tactic 2. Tactic 2 did rely on those high frequency codes more and didn't use the redundant codes. And you can see that a little bit better here. So when the top three words come to mind, we can see that there is a little more variability across the board. And you can really see that with the redundant codes here. So celebration of veterans over here, you can see Tactic 2, Tactic 1 a little bit, but then Veterans Day celebration of redundant code brought up by Tactic 1. Tactic 1 is still using that, but the second run didn't pick up on that as much. So, and then something else to note is that neither AIs use some of the codes at the very end that Tactic 1 came up with. And this is something that we wanted to go back to our coding team for and just let them know. So overall, human and AI coders don't always agree, but in the right circumstances, AI coding produces good reliability. And it really comes down to your coding frame. And this is true for humans and for AI. You need that coding frame to be perfectly in place and feel good about it to come up with the best way to organize and code your open ends. So yeah, thank you so much.
Awesome. Well, thanks, Sarah. So now our panelists have finished their presentations. So I was a very diverse and insightful topics around survey research and analysis. I know we only have a few minutes, but I would still like to kind of kick off this Q&A session. So let us know if you have any questions from the among the audience. Any questions?
While we wait for questions to come in, I do have one of my own for Hanyu on her presentation, just around the specifics of how you fine tune that model. How, as a kind of AI neophyte, how do you do that? Is that something you do through prompts? Do you kind of feed in the data to the AI? If you could talk a little bit more about how one would get started with that, I think that would be useful for me.
Sure. So I think the first one is first thing first, you need to have access to a GPU machine that can host and run a large language model. So once you have that hardware set up, you can go to Hugging Face or other places to download the model. And what we do, as I described in my presentation, is you have the whole concept of fine tuning is you have a labeled, smaller label data set. So you can fine tune the top layers of the large language model. So as in my example, we human coded transcripts from kind of interviews. And then as any machine learning model approach, you use like 80% or 80% for training the model and like 20% also to test the model performance. So what you do is you download a model, you put them into Python, you have that training data set ready, you feed that into the model. Of course, you need to have a prompt. So that's the prompt I showed on my slides. So it's very similar if you're familiar with any other type of machine learning. So you train the model with a small data set, you test its performance on the 30%. So that's how it works. But it all starts with you have access to a GPU machine.
Awesome, thanks. So we have a question from Nicole. So when using client data to analyze or code data, are there any privacy concern with putting that data
Absolutely.
as it uses that data to fuel its model?
Yeah, so definitely don't be giving a third party large language model access to your client data without the permission of your company's security policies. Usually what we've done is that we have special agreements with like say OpenAI or Anthropic that uses a 0-day retention policy to make sure that any data that's sent it gets erased on the third-party servers. Now, whether that works for your organization, I don't know. But definitely, you want to make sure that you're in compliance with your organization's security policies and such.
So that's why I want to emphasize the difference from, the OpenAI models have access to, no, and large language model have access through internet versus open source models, as I described in my presentation. Those models you can download to a local machine and disconnected. It's not connected to the internet. You can train the data and fine tune the data within the Wi-Fi or network. So that's one approach as compared to, ChatGPT-4, you have access to internet, all the data being provided to their end and fine-tuning their model. So that's one option.
And there are large language models that run small enough that they can be run on a desktop, but they're not going to be as
High performance,
fast
yeah, no.
and as performative. But you can look into those as well, and they can be useful.
Awesome, thanks. And then one question to Tom. So how did you handle false positive and negatives, and what did the feedback loop look like?
There were a few different ways we captured it. There's actually a couple of built-in processes in our workflow where our project teams are able to report if we need to remove respondents who were missed by quality score, and we're able to document that. We're then able to take that data and bring that back to our developer team and do iterations of our model based on it. But I think the most important thing that we had was we have a task force of stakeholders from all different divisions in Dynata who come together, meet on a regular basis, and communicate what's working, what's not working, where we're seeing common trends, and kind of creates that environment where we're all looking at the same results and end goals. So the documentation part, obviously have a process and stick to it. Make sure it's something your users are going to be able to follow. If you could put the ability to document false positives and negatives in their existing interfaces and the tools they use every day, great. But if not, make sure you're setting up the regular touch basis so that people are being heard, getting their voice brought to the table.
Awesome, thanks. And we have, yep, go ahead. Anyone? And so we have another question to Tom. What AI model or system did you use for the data cleaning project?
It is a proprietary model that we built on our back end, so it's not something out on the open web.
Awesome. I think we can probably take this one last question. So to Sarah, so both humans and AI can make mistakes. So from your perspective, do you think is AI better than human overall?
That's a tricky question. I wouldn't go as far to say that AI is better than humans overall. It's interesting to note like what types of errors come up for humans versus AI. And I think we're still in a very iterative process with getting AI kind of up to par. I would not rely on AI solely to code your open-end data, right? But it is a powerful tool in including it in that analysis, especially back to what we were saying about client data and utilizing that. If they were interested or if it was public facing data that they were comfortable with, and obviously having something signed and having that conversation is of the utmost importance, but you could see a different view or maybe an extra view that helps your argument with the human coding. So we're not there yet, but I would say it is a topic of conversation that is very important and something that you could utilize. Again, make sure that you know what your training model looks like, sure you know what your coding frame looks like, something to use and to bolster, but not to replace humans, especially not right now, in my opinion.
Well, and humans are the benchmark for whether it's accurate or
Exactly.
not. So like what the machines understand the data a little bit differently than humans, and so it's really just whether or not AI is mimicking the humans or not, or whether it's saving you time.
Yeah, and we're getting there,
Yeah,
so we'll keep going back and forth with the models that we have. But it can help save time if, again, the client agrees. Something to bolster and something that I think we'll keep working towards.
Got it. Well, thanks. I think we are right on time. And thanks again to all the panelists who, to present such a very diverse and insightful topics. And also thanks to the audience. So I'm going to pass it to Patrick to help close today's session. Patrick?
Yeah. So as Travis mentioned, just want to thank everybody for joining us today, as well as thank you, Travis, and the rest of the NEAAPOR Executive Council for help planning all of this and putting it all together. So again, thank you. We'll talk about potentially sharing out the slides if anybody's interested, so we can potentially follow up on that. But again, as I mentioned, thanks again, and keep an eye out for our spring webinar coming up in March or April of 2026. With that, we'll let you get back to your day.
Thank you.
Thank you.
Thank you.
Thank you, everybody.
Take care.